when it comes to pass by reference versus pass by value, we're going to walk through a few examples of things that you've probably already seen, but you probably might not have thought of super in depth as to exactly why that is or is not happening. Okay, so let's start with a few examples of code. So one of the first things that we talked about in the way back when, 2 or 3 weeks ago, was this idea of primitive values in JavaScript versus complex values, right? Primitives are numbers, booleans, strings, etc., and the complex are the objects, arrays, functions, etc. And we said the main difference between the two was that once you create a primitive, you are never going to be able to change that primitive value, right? Whereas for a complex value, once you create an object or an array, it's actually pretty easy for you to edit that object or that array, right? To keep adding things to it, add elements, add fields, etc. And so, because we know that strings, for example, are primitive values, which means we can't change it, let's take a look at this sequence of events here. On line 2, we have a variable called British City, and we set it equal to the string York. On line 3, we have this variable called American City, and we set it equal to British City. Now, on line 5, we then reset American City to equal the string new plus the string American City. So effectively what we're doing is we're overwriting the previous value of American City now with a new value of American City. And so after line 5, when I console log out both British City and American City, we'll see that American City becomes New York, but British City is still York, right? And so what we really want to drive here is this idea that on line 2 there, right, British City is equal to York, and on line 3, even though I set American City equal to British City, whenever I edited American City, those changes were not reflected upon British City, because once again, remember, we are not able to change British City, right? British City is always going to be York unless we redefine it. And so on this page, we never redefined British City, and that's why it stays York. On line 5, we see that we redefined American City, right? Because it's American City equals something else. And so because of that, the value for American City has changed, but the value for British City has not changed. So why am I kind of really harping on this particular idea? Because if we take a look at complex values, we'll actually see a different set of behaviors. On line 2 here, we have this variable called British City, and we set it equal to an array with one element, which is York. On line 3, we then created a variable called American City, and we set it equal to the variable British City. And here on line 5, what we do is we call American City.unshift. And remember what unshift does is unshift adds an element to the beginning of the array, right? So here on line 5, what we're saying is go to American City and let's add the string new as the first element in the array. And now when I console log out both British City and American City, I get back an array with 2 string elements, and we didn't print out the quotes here, but essentially we get back an array with 2 elements, new and York. And so here the difference between this example and the previous one is on line 5, we only changed American City, right? We unshifted American City with the string new, but somehow those changes were reflected both in American City, which we saw in the last example, but it was also reflected in British City, which we did not see in the previous example. And so today's lesson is really just about kind of why this is happening and kind of how we understand this to make sure that something actually fairly simple doesn't confuse us or cause problems in our code down the road. Okay. So the difference between these two has to go back to this idea of primitive values versus complex values, right? Primitive values are not changeable. And so whenever we create, or rather whenever we assign a primitive value to a variable, what the variable actually does is it actually stores a copy of that value. And so in the bottom right hand corner here, we'll use some variables and arrows to hopefully make life a little bit easier for us, right? On line 4 there, we create a variable called first, and we set it equal to the number 20, right? And so on the left hand side in the box in the bottom right hand corner of your screen, right, the variable is first and it points to a value called 20. Now on line 5, when we reassign the variable first to the value 30, we basically take that arrow from first and we point it to a new value called 30. If on the other hand I actually have another value called second, And I'm just going to exit out the screen really quickly while I move this, move the zoom thing. Okay. So, sorry. So on line 7, when I create another variable called second and I set it equal to 30, even though the values are identical, hopefully I think this makes sense to most people kind of off the bat intuitively, right? Even though I have two number 30s, they're different versions of 30, right? And so on line 7, that second variable points to its own version of 30, which is why when I increment that second variable by 1, so I set second equal to its current value plus 1, the second value now points to 31, and the first value is not affected. Okay? So this is a pretty basic example and just kind of highlights the fact that when I set multiple things equal to the same value, they are set to the same value, but they're different copies of the same value. In this case, between lines 5 and 7, even both variables first and second equal 30, but they're different versions of 30, or rather they're their own different copies of 30. Now, what happens then if we do something like this? I say let first equal 20, and then on line 2, I say let second equal first. Here is where the idea of pass by reference versus pass by value comes in, right? And kind of the rule of thumb here to remember is that when it comes to primitives, what we always do is we're always passing by value. And what passing by value means is if I'm trying to assign a variable equal to a value, what I do is I take a copy of that value and I store another copy of that value in the variable. So on line 1, I say let first equal 20, right? So I see the first arrow that draws from the variable first to the value 20. On the second line, I say let the variable second equal first. Well, the variable second then points to whatever first is. And what is first? First is 20, which is a primitive value. And so therefore, we're not going to point our arrow from the second variable to that version of 20. What we're going to do is we're going to make our own copy of 20 and point an arrow to it. And so that's why on the bottom right-hand corner of your screen, we see we have two variables, first and second. They both point to a value of 20, but those two 20s are different because the second 20 is a copy of the first one, right? If I gave you a piece of paper with some notes on it and you make a Xerox copy of it, well, now we have two versions of that paper, and whatever I write on the second version doesn't affect the first version. Same idea here, right? Because that 20 is a copy of the first 20, on line 4, when I increment that second variable by 1, it has no effect on whatever the value in the first variable was, right? Because once again, even though both variables were equal to 20, they're different versions of 20, or one is a copy of another. So whatever I do to the copy does not impact the original. Okay. Everyone good so far? Great, awesome. Okay, so that makes sense for primitives. Now let's do the same example, but let's see what happens when we move on to complex values. The short of it is, with complex values, we don't store a copy of the value. What we store is we store a reference, right? Or put another way is we actually store that value, that version of that value directly. And so when we do that, what we say is we store our reference in memory to that value. So we'll talk a little bit more about what that means in a little bit, okay? So here on line 7, we have this variable called first, and we set it equal to the array with two numbers, 10, 20, okay? And so this is still happening in the previous example, but we ignored it. But here, just to kind of be even more clear, right? We have our variable first. It's pointing to a reference, right? And the reference you can almost think about as an address, right? Or basically a computer in a computer, or sorry, a location on the computer's, let's say, memory chip that is actually storing that value, okay? Like, because if I'm storing a value, it physically has to be somewhere on the computer. The reference is just the address in the memory where that value is physically being stored, okay? So I have my variable first. My address for that value is 0x001, and at that address, it tells me the value is the array 10, 20. Now, if I want to, for example, push 30, right, push the number 30 into the array, remember, complex values means I am able to change it on the fly, right? I don't need to kind of make another copy of it, right? So there, if I want to push in 30 into the value, I don't change the address, I just add 30 to the address, right? Because, and this is a little bit just kind of a side note, but typically when we talk about addresses or memory in computers, we talk about where the what the address of the initial value is. And the initial value will point you to the next value and next value all the way until you get to the end. So that's why in this case, because I'm adding, for example, 30 to the end of the array, my address doesn't change because I'm able to change this complex value. And when I print it out, I get back 10, 20, 30. Okay, so very basic. Yep. It's an arbitrary example we're using for now in this slide. In the next couple of slides, you'll see why we use it. Yep. Yeah, no, this in itself doesn't. Although at some point, if you do want to write kind of lower level code, you want to manipulate the memory in which things are being stored, like you're able to use it. So for us, practically speaking, no, but like there is like a theoretical use case for it. Yep. Okay, so we go back to our example from earlier, right? This example, I think most folks, once again, pretty intuitively understand. Even though on line 3 I have my second variable, I set equal to the same exact, to an array with the same values, it's pretty clear these two arrays are, even though they have the same values, they're different, right? They have no relation to each other, right? And that's why the second variable is being stored at a different address, and that address happens to have a value that's identical to the previous one. But once again, there's nothing linking the two, right? The example the analogy I give here is that, if I have a Toyota Camry and my friend has a Toyota Camry, like we both have two versions of the same car, but they're clearly not the same car, right? Like, because we have our own different versions of it. And so this is just to kind of highlight the fact that even just because two values are the same, it doesn't mean that they are stored at the same place in memory. Okay. So that's why the reference for one is 0x001 and the other one is 0x002. Okay. Now let's move on to the third example, which is kind of the more tricky one. Oh, sorry, this is just to note that because they're separate, doing something to one does not impact the other. Okay. So let's move on to the third example, is where things get a little bit more tricky, right? Which is first equals this, and then now let's say let's second equal first. And here's where complex values differ than primitive values, right? Remember, if I was doing this for a primitive value, what will happen is I would take a look at whatever the value first was, make a copy of it, and then store it, right? Here, I don't actually make a copy of it. In fact, what I say is I just say, hey, look at this memory, right? Or rather, pass by reference, which means I set second equal to the same reference as first, right? Notice how in the box on the bottom right, the variables first and second both have the same reference, right? They're both 0x001. And so when I set second equal to first, what I'm saying is not just make a copy of first and then store that copy. What I'm saying is, hey, just look at actually that version of whatever value of first is. And so hopefully you can kind of see where this is going now, right? Because now, if they're both pointing to the same array, on line 7, when I tell the second variable, hey, why don't you add 30 to the end of your array, the variable second looks to the reference, which is 0x001, and then I go to the value, I add 30 to the end of that array, and voila, if I look on the bottom right-hand corner of my screen, my value is now the array with values 10, 20, 30, but when I console log out first and second, they're the same, right? And so once again, this now kind of brings full circle what we saw earlier, which is that I set second equal to first, and by changing second, I was also able to change first. And this is, once again, happens because with complex data types, these two values are both pointing to the same reference. Whereas with primitive data types, they only point to the same value, right? Or rather, one points to a copy of another value. Whereas with complex, we actually are dealing with the same instance or the same version of that value. Everyone good so far? Yes. Exactly. Yep. Yep. Cool. So, And then, and so if we go back to our session that we did on arrays, maybe 2, 3, or actually maybe late last week, now we can kind of see why the dot slice function for arrays is really powerful, right? Because if we look at what slice is doing behind the scenes, what slice is doing is slice is actually creating a copy of an array. And so here, my first is an array of 10, 20. If I do first dot slice and store it under second, well, my variables first and second are now pointing to different references. The references have the same value, but they're different versions of the same value. And so once again, I go back to my kind of more comfortable setting where whatever I do to one array does not impact the other array. And so this is why, generally speaking, if you have a complex data type and you want to play around with it, but you don't want to make those changes permanent, you almost always want to kind of make a copy of it first. Okay, so where do we actually see this more in real life? Well, here all I did was assign one variable to another variable, right? Which may seem like kind of we're doing so just for the purposes of teaching this lesson. But the truth is we actually see this very often. We've seen it in every single class so far. And the most common place that we've seen this actually is when we pass in inputs into functions, right? So on line 1, we have a variable called mynum. We set equal to the number 10. On line 3 through 6, we define a function called adds20 that takes in a number, we add 20 to it, and then we return the number. On line 8, we're actually going to run that adds20 function. We're going to pass in mynum, and we're going to store the output in this variable called return num. So, well, I guess I kind of spoiled it a little bit, but let's kind of walk through what's happening here, right? Really, the first line of action, if you want to call it that, is actually on line 8, right? On the right-hand side where we actually invoke adds20 and we pass in mynum. Now, we know mynum is 10, so when it goes into the adds20 function, right, on line 3 there, the parameter num becomes the value 10. And so on line 4, we say 10 equals 10 plus 20, which is 30. And on line 5, we say let's return 30, right? We return 30 to the right-hand side of line 8. And so line 8, let return num becomes 30, okay? The big question now is not what return num is, because we know return num is 30. The question is, did we or did we not also change mynum, right? Because on line 8, we passed mynum into the adds20 function, and we clearly see that adds20 function modifies num, right? It redefines it there on line 4. But here's where the idea of pass by value versus pass by reference becomes really important, because once again, numbers are primitives, and so with primitives, we pass by value. And so what that means is on line 8 there, when we pass in mynum into the adds20 function, we're not passing in that version of mynum. What we're doing is we're copying that value of mynum, which is 10, and passing in a separate version or a separate instance of the number 10 into the adds20 function. And so there, even though we're saying num equals 10, num plus equal 20, let's return num, what we're doing is we're changing that copied version of num, right? Or that copied version of mynum, sorry. We're changing a copied version of mynum. It's like we Xerox mynum, and we're doing all this work on a Xerox copy of it, but it does not change the original. And so therefore, mynum is still 10 when everything's said and done. Let's contrast with the complex values, right? Here, the layout looks the exact same as before. I have a variable called myArray. It's the array with the number 10 in it. On line 3 through 6, I have a function called pushes20. It takes in an array. On line 4, I add the number 20 into the array, and I return the array. And on line 8, I invoke the pushes20 function, right? So almost identical to what we were seeing on the previous page. If I walk through the same sequence again, on line 8, I invoke pushes20 on the right-hand side of the equal sign, and I pass in my array. What happens to my array? On line 3, it becomes array. On line 4, we add 20 into it. On line 5, we return that array. And on line 8, we capture or we store that return array in this variable called return array. Now, what happens to my array? Well, because my array is an array, it's a complex data type. And so when we pass in my array into the pushes20 function there on line 8 and then subsequently on line 3, we're not passing a copy of my array. We are literally passing in that version of my array. And so that version of my array gets 20 pushed to the end of it on line 4 and then returned on line 5. And so now when I look at both my array and also the return array, I get back the same values because guess what? They are the same array, right? Like when I pass it into pushes20 on line 8 there, I'm not passing a copy, I am passing in that version, right? I am passing in that reference to my array. And so, like I said, this is something that we've seen very, very often so far, in almost every workshop, right? What we've done is we've written functions and we pass in values and see what happens. But we've been a little bit kind of, maybe fast and loose with what's happening behind the scenes. And now we're just trying to clarify some of the details around what's actually happening. Okay, any questions up to now before I move on to the shallow versus deep copies?
I have a bit of a question.
Go ahead.
Online, so I don't know if this really has so much to do with the content. Online three, the link type array is for this there. That's like the parameter 20 is the link string. What happens? We're an array, or is there a placeholder in column use for an array to
So the answer is we don't have to call it array. We can call it any variable we want because a parameter is just a variable. So we can call it Lorem, we can call it anything we wanted to do. But we need a variable there so we can reference that value later, or so we can use that value later on, right? If it's just empty parentheses and there's nothing in there, then when I want to access the value, I have nothing to use to access it. Yes, and the reason I'm a bit tentative is we technically store the value on line 3 when we invoke our array initially, but the first time we use that value is on line 4, correct? Cool. Any other questions? Sorry, Arjun, is that you? Okay. Sorry, go ahead.
Is there an advantage to, instead of copying the references or copying the values, to lead them to the same reference?
Well, I mean, so kind of like the theory behind it is that because primitives and strings and numbers cannot be changed, if I am pointing you to a value, well, that value is never going to change, right? And indeed, if I do want to change it, I kind of want to have my own copy of it to play around with. With complex data types, if I'm passing a value to you, the idea is that that value can change. And so I want to make sure you're kind of always up to date. And so you have the latest and greatest version or the correct version of that complex value. And so that's why I would rather give you the reference. It's kind of a design choice made, by JavaScript. Not every single language, I believe, does it the same exact way. And so this is kind of one of those things that's like, with the folks who wrote JavaScript made a very conscious decision to say we want to do, reference passing in this way. Beyond that, I don't think I have a much better answer as to kind of whether that's correct or that's best. That's probably more of an opinion and based on what your use cases are, but that's at least the design principle that JavaScript chose.
Thanks.
Yeah. Cool. So just moving on to the kind of the last, oh, and sorry, a quick detour here, right? So now if you remember, or actually I think Alec taught this lesson, so I'm not sure if he mentioned this to you guys, but like here in this bootcamp and really in JavaScript in general, right? We always want you to use the triple equal sign rather than the double equal sign. And the reason why is just because hopefully now it becomes a bit more clear, right? If I'm trying to compare two things, what the triple equal sign is, for primitives, it doesn't matter, right? Because it only compares it based on values. For complex values, when I use triple equal signs, what I'm doing is I'm actually not comparing it by the values, I'm actually comparing it by the reference. And so what does that mean? Well, on line 3 and 4 there, array 1 and array 2 have the same exact values, but they have different references because they're not intertwined, they're not related or linked together in any way, right? They're the same values but tied to different variables. And so therefore, when I use array 1, I set it equal to triple equals to array 2, the answer I get back is false, because those two variables have different references. They just happen to have the same value. On the other hand, if I do something like this now, array 1 equals this array 2 equals array 1, well, now these two variables share the same reference. And so because of that, if I do array 1 triple equal array 2, I get back true. And so this is just something to be careful about when you're using triple equal signs with complex values, is that remember that with primitives it compares it by values. With complex values it compares it by reference, not values. Although, just hopefully by now this is hopefully a little bit more clear to you. If two variables have the same reference, then they by definition have to have the same value, right? Because if it's like if both variables are saying my value is stored here, then they must be both they both must then they both must be pointing to the same value. Okay. So the last thing we'll talk about is this idea of slice, and kind of revisit it a little bit in more detail. Earlier we showed that slice creates a copy of an array. And so here on line 4, if I do array2 equals array1 dot slice of this nested array, if I look at array2 and array1, I see that array2, we talked about how when I make a slice of an array, I'm basically making a copy of it, right? So when I slice array2, or sorry, when I slice array1 and store the result value in array2, it makes sense that array1 does not equal array2, right? Because they're copies now; they're no longer linked together. But one of the things that we kind of glossed over in that previous example was there was a nested array inside that initial array. So what happens to that nested array? Is that also sliced, or do we pass in that version of that, or do we pass in that reference of that array into the newer copy? And so let's revisit this example in more detail here, right? Array1 equals this nested array. Array2 equals the array1 dot slice. Now, if I go into array1 and I go into the second element, right, which is that nested array, and I push 4 into it. When I console log out array2 and the second element, notice how the 4 also got pushed into the sliced array, right? And at first that may not make sense because we're like, well, we sliced it; those two should no longer be linked. But this gives this idea of a shallow copy, which is what slice does, right? What a shallow copy does is it says, I am only going to copy the outermost level of information, right? And so what that means for array 1 is I'm only going to copy the 1 and then any other primitive values you have in there. If, on the other hand, in the array you have a complex value, I'm just going to pass in that complex values reference into the copy. And so on line 13 there, right, if I take a look at array 1 and take a look at array 2 and I compared the nested array inside of it, notice how the triple equal sign for them is true, because those two values are the same reference, which boils down once again to this idea that when I use dot slice makes a shallow copy. It only copies the outermost level of information. For anything complex inside the array, it will still pass the reference. And so, and generally speaking, when we use dot slice, we walk away thinking that, oh great, I now have a copy of the original array that will no longer impact the original array. But that's not always the case, especially in instances in which we have nested arrays. Just to be aware, there is still a link between the two.
Hey, David.
Yeah.
Can you go back? So after doing all that, and you change the first index one, right?
Mm-hmm.
If you console log array 1 again, will it be 1, 2, 3 or 1, 2, 3, 4?
It'll be 1, 2, 3, 4. Because
so array 1 gets changed because the first index got changed.
Right, on line 10 there, we directly changed array 1, index 1.
Okay.
Right, so we directly changed array 1, index 1, so that will 100% definitely be changed. But like kind of nuance here is that array 2, index 1 also got changed, right? And the reason for that, once again, on line 13 is because array 1, index 1 and array 2, index 1 share the same reference. And so whatever changes we make to one, by definition, will be reflected in the other as well.
So you were saying that it's only going to copy the outermost values and
Yep.
any primitive values? So
Yep.
what would have happened if array 1 was longer, like it was 1 and then that array was 2 and 3 and then comma, I don't know, 5 or something?
Yeah, so it will copy 1, 5 as primitives. It will copy the values of them, but it will still pass in the 2 or 3 reference. So it doesn't stop once it hits a complex value. It just passes a reference, right? So as it goes through every element in the array, it'll make a decision. If it's a primitive, I'll copy the value. If it's a complex, I'll copy the reference.
Hey, David, not to belabor it. So I get it. So array 1, after doing all this, array 1 becomes 1, comma, bracket 2, 3, 4. If you console log array 2, it will also be 1, comma, 2, 3, 4.
Yep.
Okay.
Yep. Any other questions on this? Cool. So once again, right, this is something called a shallow copy. And so the flip side of this would be something called a deep copy. A deep copy is something that we don't talk about too much in this class, except to just let you know that it exists. And there are ways to make deep copies of things, right? So usually it's more of a recursive process because generally speaking, when you make a deep copy, you don't actually know how deep you need to go, and so you kind of want to do it in a way that's kind of self-fulfilling, right? You want to keep doing it until it gets to the bottom of things. But here we just want to kind of let you open your mind to this idea of a shallow copy versus a deep copy, and more important, to let you know that .slice makes shallow copies, right? So generally speaking, when you use .slice, you can walk away thinking you have a safe copied version of the array that you can use, but that's not always the case, once again, because of this idea of shallow copies. So just to recap today, we talked about primitive versus complex data types, and more importantly, kind of how the, oh, sorry.
Can you go back to that for
Sure.
literally just 30 seconds? Not even. Just 1 sec.
Yep.
All right, sorry about that. You can continue.
Cool. Yeah. So just to recap, today we talked about primitive versus complex data types, and more importantly, how that affects the way I assign variables, and also how I use those variables, right? Like when I move from one place to another, am I moving a copy of that variable, which is the case with primitives, or am I moving a reference to that specific version of that variable, which is what happens with complex values. We talked a little bit about how the triple equal sign then for complex values actually isn't comparing two complex objects by their values, we're comparing them by their references. And we also talked a little bit about how .slice then allows you to make copies of arrays, but it has limits, especially when the array is nested, because .slice will only make a copy of the outermost level of information. And if I have inner elements are complex, then .slice will just make a copy of that reference rather than a copy of that value of that inner element. So, any questions before we break up for the workshop?
Yeah, so one last question. So if you go back to the slide, I was just wondering if there was a way to, with the slice, it removed the 1, but is there any way to remove the 2 and 3 out of the array 1?
Yeah, so remember how .slice takes up to 2 arguments. The first argument is the index at which you start, and the second argument is at what point you stop, but before you reach it. So if I start at index 0, if I do .slice, the first argument is 0, that means I start at the first element, and then comma 1, which means stop. I stop before I get to the second element. Then that will create an array that only has 1 element, which is the first number, which is 1.
Dave, can you continue that? Just like click forward 2 more times so the console logs show up. Thanks.
Yep.
Okay, thanks.
Yeah. Did that make sense, or did you want me to see it?
Yeah, could you?
Sure, no problem. So let me just copy this snippet here. I'll go here. Okay, great. So here, if I do array 2, it gets back this, right? This is a copy of it. If I just do something like 0, comma 1, this means start at the first element, stop before I get to index 1, so stop before I get to the second element. And when I do that, and do array 2 now, array 2 becomes just an array with just the first element.
I mean, for it to cut out 1, 2, and 3.
So you want an empty array?
Yeah. Like empty it and then put something else back in it, because what we did, we put a 4 in there. We pushed a 4. So I was just wondering if there was a way to clear it all out and then push a 4, so that way the array
Well,
1.
so it's hard. So we can't. Sorry. So okay. So if we empty out the array, then there's nothing in there, and so there's nothing to push into, right? Because pushing into assumes that your second element is an array.
Okay, so then could you push something and then empty out everything else but the 4? So like push 4 and then slice the 1, 2, and 3. Would that work?
So what do you want your output to look like?
4.
Like an array with 4, like that?
Yeah.
You're not really. I mean, at this point, you're not really even like copying the array anymore, right? Like you're just creating a new array with an element that you want inside of it. So if I really, so let's just go through here, right? Let's see if there's kind of a creative way for us to do this. I could say array dot slice, right? So let's say I only want the first element, and so I'll just do this in this stepwise manner, so you can kind of, hopefully we can get there together. Okay, so array 2 is slice at index. Oh, sorry. So now I have 2, 3, and 4, right? And so then, so this gives me an array. So then if I do array, okay. So then if I chain this together, I do dot slice, what would it be? Yeah, I mean, then I would need to, because what slice will do is slice will always put an array around whatever it is you want. So then you would actually just need to access this, and then do another dot slice. And then it would be 0, 1, 2, 2, comma 3. Okay, so that gets you to the 4. So, I mean, there is a way to do it, but it's like, I guess it's like then you're kind of moving to territory where slice is probably not the best tool for you to be using, and you should probably be looking at something else.
All right, on the slides, the second to last slide.
Yeah.
Sorry, I'm going back to it again.
Sure.
All right, so I thought the whole point of using the slice was to make a copy that isn't tied to the same reference. So you're making an array 2 that is equal to array 1, but not with the same reference.
So basically what I'm doing here is
You're copying array 1.
Yes.
The same reference.
Right. So basically
So my question is that then why on the next line of code when you alter array 1 does it go back and alter array 2? So I thought the whole point of using .slice was to create an independent array.
yeah, I'm trying to think what's the best way to show. Like, I wish we were in person, because then I could just like write it out.
Wasn't the moral of that story that because it's only a shallow copy?
Yeah, no, that's true. That was a moral story. So I'm glad so I'm glad part of that came through. There is an easy way to kind of show this more graphically speaking.
Can you just put it? Can you just write it out and then console log each level of it so we can see what it looks like?
Yeah, that would help.
Console. Well, so the console log for the problem is the console log for each level is going to look identical.
Well, what was tricky for me though was that in the second to last slide, when it was console logged, it was only console logged at index 1. I mean, I don't know.
So here?
Maybe I'm just, I'm not very clever, so maybe that didn't confuse other people. But
So in this example, let's say if instead of saying array 1 dot push 4, if you had done like array dot shift or unshift a number, that number would appear in array 2, but not in array, Or would appear in array 1 but not in array 2, correct?
Sorry, say that one more time.
So on that slide right there,
Yep.
if you were going and editing not the nested array, but the outer array, that wouldn't have appeared in array 1.
Right. Yep.
So if I had done like an unshift there, it would have only appeared in array 2 and not array 1.
Yep.
Okay.
So I guess for folks' benefit, I'll try to make, I guess, like a version of clip art, if you will. Just bear with me for like 2 seconds here, right? So if I have something like okay, actually, you know what? I'm gonna do this in how do I? Okay, I don't even know how to use Keynote. It's just painful. Yeah. Okay, let's try to get Word open here.
Like insert a bit box.
Yeah, I just want to insert some diagrams here. Maybe PowerPoint would have been easier, but whatever. Let's just go for Word here, because so basically, if I was to okay, so let's just say I have so let's say I have two really massive okay. Okay, so this is one, and then I will copy this. Okay. Okay, so this is going to be a bit painful, but the idea here then is that if this top row is array 1, and then this here is array 2. Oh my god, this is so okay, great. All right, great. So the 1 and the 1 are distinct, right? So whatever I change to this 1 will not affect the change to array 1. But when I make a shallow copy, well, the problem that I actually end up getting is something like this now. They both share this version of 2, right? So even though when I look at and so let's say there was also a 5 at the end of it, then what will happen is this would be 5, and then this would also be 5. And so if I was to read array 1, the values would be 1, 2, and then 5, right? Array 2 would be 1, 2, and 5. Whatever I change to this 1 would not affect either version of the array, because these are two distinct copies. And same for the 5. But the second element, this is a complex value. So actually, let me change this. This should be like, this example, this is our 2, 3, right? This complex value, when we use sliced, it made a shallow copy, which means that it didn't, for the 1, it made a copy of the 1, copy of the value into array 2, right? We made a copy of the value of 5 into array 2. But because this inner nested element is an array, when we made a copy, we didn't copy the values of this 2, 3, we just copied the reference over. And so essentially the reason why I'm having this box overlap both array 1 and array 2 is to show that these two are actually the same reference, they're tied to the same value. And so if I go into array 2's second element and I push in an extra 4 here, well, in array 1 then, I've also pushed in an element 4, because once again, the first element, or rather the second element in both array 1 and array 2 are overlapping. They're the same, they share the same reference still.
That's brilliant. I like it.
Very nice example.
That's a great.
Very beautiful.
Awesome, great. I'm glad I wasn't in vain. Yeah. So yeah. So that's kind of the idea of shallow copy, is that, you know, like if I'm looking at these two elements, it's like, oh, great, I've done exactly what I want to do. I've created separate, distinct versions of it, and I can kind of play around with it. But then this person, or this little fellow in the middle, is still kind of problematic, because this is the reference that's being passed back and forth, right? And so if I go back to the slide here, then that big box that overlapped both categories, that's what the second element is, right? So here, when we compare the second element and the second element, we want to use a triple equal sign here to kind of drive home the point that these two, when I compare with triple equal signs, they share the same reference, because they are the same thing, and that's why those two are equal, and the slice kind of didn't finish the job, if you will.
You
So
should add that chart into this presentation.
Great, yeah, yeah, I will do it. Yeah, we actually should have the slide somehow convey that message. Yeah, so for you guys, I guess I made it live, but in future classes. Yeah.
Would
Well,
the situation be different if there was a 0 there, or if there was a 3?
yeah. So if I was to do something like this now, this would now be
Yeah.
false. Or actually, no, this would still be true because then I'm comparing the number one to the number one, and the ones are primitives, right? So we only compare them based on value. But if I was to do something like this altogether, like array one equals array two, this would now be false,
Okay.
right? So I'll just
Alright.
yeah, we can just really easily prove it here too as well, just so we can see it. So if I do array 2 index 1 equals array 1 index 1, I get back true because it's a reference. But if I'm just comparing the arrays kind of out of box, I'm going to get back false, right? Because half of it is equal, half of it is not equal. And so by definition, it means it's not equal.
A question that doesn't have much to do with this concept.
Sure.
A minute ago, you were doing some other manipulations on line 2 and you just deleted them.
Oh, yeah, totally. I can
Um,
bring this back.
yeah. Can you just explain to me how, like, that's when my brain is like, I don't even know what that means. Can you, like, describe line 2 in English?
Sure. So let me, what's my best way to do this? Okay, so I'm just going to do this line by line. Just bear with me for like 30 seconds here, okay?
Yeah, sure.
Okay, cool. So array 1 is equal to
Right?
that, right?
Yep.
So array 2 slice 1 comma 2 is equal to that. Okay. Array 2 is now, oh, sorry. It's then equal to this. And then that is equal to this. Does that make sense? Hello?
Yeah, I'm sorry, it got noisy where I am. Sorry.
Yeah.
No, sorry, David. Can you go over that again? Sorry.
Okay, so in the first step, array 1 is equal to this array here, right? So I haven't made any changes yet. This is exactly what it is. On the second line, when I do array 1 dot slice, so I'm basically so this is a chaining process, right? Like I'm basically saying, do this, then this, then this, then this. And here, all I'm doing is I'm just breaking it down like operation by operation, so you kind of see in each operation where I am, right, or what my output is. So when I do array 1, that's my output, right? So when I do array 1 dot slice 1 comma 2, remember slice, the first argument says that's the element in which I want to start at. So I want to start at index 1, so that's this element here. And I want to stop before I get to the next element. So basically all that does is now this, I just basically extracted this one element, right? This inner nested array.
Yes.
So then when I do index 0 of that basically says, hey, in this array, give me your first element, right? And there's only one element here. So I'm now back to this array. And then if I build on top of that dot slice 2 comma 3, that basically says go to the third element, index 2, give me that element and stop before you get to the next element, right? So basically now what I've done is I've just extracted the 4 out. And I believe, I forgot who asked the question, but the premise of this was to say, how can I get from this to just a 4? And this is how I would do it.
I guess my question is, how did you know? Okay, so when you did the bracket 0 index on line 6, that was just to get the array unnested, basically.
Exactly. Yep. Because and that's kind of one of the tricky things, is that dot slice always gives you back an array. And so if my inner element is an array, then whenever I use dot slice, it will always wrap it in an extra array. So I just need to kind of take out that layer of array.
And the bracket 0 does that? It removes it?
Yeah, so bracket 0, all it does is it takes the first element out of the array. And so if I look at line 5 here, this outer array, there's only one element, right? And the element is just this. So when I do bracket 0, all it does is it takes out that element. And that's what I'm left with here on line 6, right? On line 5, if I take the first element out of this nested array, I'm left with just this inner array.
If you repeated line 6 again, would it break it down to just individual numbers?
Yep.
Or a string?
Yep. So your question is, if I do something like, like this now, right? If I do a 0, then I would be left
Exactly.
with just a 2.
Okay, thank you.
Yep. Cool. Any other questions? Let's go back to the summary page so we can kind of all see. Okay. Cool. All right. We have about 2 hours left, so I will let you. I'll get started on the workshop. Unless I think someone just unmuted. Was there a question?
Yeah, sorry, like very, very simple question.
Sure.
Where would you get the sliced 0, 1?
Where?
In, say, line 6.
On line 6, if I sliced here, you mean?
Yeah.
Well, if I do array dot, so if I just do something separate here, like say array 1 dot slice 0 comma 1, what that means is start at the first element, right, index 0, which is in this case is a 1, and then stop before I get to the next element. So I would just be left with that.
Sorry, I meant slicing at the 0 index. So
Sorry, I'm not following.
the 0 index on line 6 is the array 2, 3, 4, right?
Oh, sorry, this is not a slice. This is just accessing with bracket notation the first element in the array.
Okay.
I was actually pretty curious about that too. On that array dot slice, if you had just gotten rid of the 2 there, would it still have worked? Because it would be just 1 to the end of the element.
Yeah, it would have worked.
Okay.
Yep.
So what makes I'm sorry, like this worse, but so basically the bracket notation that you use there just says return whatever is in position 0 now.
Yep.
But what makes that a function? Is it because secretly arrays are going to behave like functions?
Sorry, what makes what a function?
I don't even know how to ask the question right. I guess, so I mean, it says, okay, whatever you have in array 1 now, just return what's at position 0. But
Okay.
why is it returning it? Like, seems like
Like why does
array 1 is a function.
like why does this give me back like 1?
Right. Like, why does that, like, I wouldn't have, I guess I just wasn't totally clear that that was invoking something, but it is.
I guess I'll refer back to the slides we did on kind of the first day on arrays. We talked about accessing elements and arrays. Bracket notation is basically the way to access elements in arrays. I guess I've never thought of them as functions, but I guess performance-wise, like that is what we're doing, right? It's like it's a function that takes in a number, which is a position, and it gives you back the thing at that position. So I guess we could think of it that way, but yeah, like we could think of it that way, but yeah, the bracket notation is more or less kind of like the default way that we access things in arrays.
Right.
And even though we don't call it a function, I guess it does behave a lot like one. Yeah, and this same for strings as well, right? If I have something like like let David equal, or let's string 1 equal David, then string 1 index 0, right, is still going to give me back the letter D. So same idea.
Yeah.
Cool. Any other questions? All right, I will stop the share, and then we will get